Lecture series on finite languages and automata theory. In today's class, we'll be discussing about Griebach normal form. This is an important question which is highly important as far as in examination perspective. And what is Griebach normal form? It actually attains two forms. You have a non-terminal on the left side and you will have a terminal. So alpha here is called as a terminal. You can have only one terminal on the right side, followed by set of non-terminals. That's why the equation is given as n tends to alpha n star. So star means n can appear, non-terminal can appear 0 or more number of times. And another form is non-terminal tends to alpha. That means you can have only one terminal on the right side. So, but there are set of preconditions or prerequisites to just work it out on Griebach normal form. So the conditions are number one, there should not be any null or unit productions. Null or unit productions. There should not be any null or unit productions. Number two, the grammar should be in Chomsky normal form. Should be in Chomsky normal form. Number three, if there is a non-terminal, then it has to be named. Then it has to be named a to the power of I in ascending order. So it has to be named in ascending order. So this is the pattern which you have to do as far as Griebach normal form is concerned. There are only two forms permitted. N tends to alpha n star, that means a terminal followed by a set of non-terminals. Or otherwise, you can have only one terminal on the right side. So these are the two forms which is permitted, and set of preconditions is there should not be any null or unit productions. If it is there, then you should eliminate that, and we have seen how to eliminate null and unit productions in the previous lectures. And you know what is meant by Chomsky normal form, so which has been already covered, Chomsky normal form. And all the non-terminals has to be named in with a to the power of I. Now I will discuss how to do this. Before going into this, that means you should know what is meant by lemma here. So lemma 1. So lemma 1, if you have if there is a production, A tends to B alpha and B tends to beta 1, beta 2 up to beta n. Then A can be rewritten as A tends to, so replace this B by beta, so beta 1 alpha, beta 2 alpha, so up to beta n alpha. So this can be replaced in this order. And lemma 2, the lemma 2 says if there is a protection of A tends to A alpha bar beta 1 bar beta 2 up to beta n. That means A tends to A alpha is called as left recursion. If that is the case, then what you have to do is you have to introduce A tends to beta 1 bar beta 2 up to beta n, followed by you introduce a new variable called as beta 1 is it, beta 2 is it, up to beta n is it. You can introduce a new variable. Now you take up this original variable, that is left recursion is there, A tends to A alpha. If that is the case, then you take up the remaining one, it's called as alpha. So alpha has to be returned with a welcome of z variable. So z tends to alpha bar alpha z. So first time you have to write simply alpha, then you have to write alpha z. And to check out with the condition, if while naming convention, if AI tends to AJ alpha, if AI tends to AJ alpha, and if I is less than J, then it is accepted by Griebach normal form. If AI tends to AJ alpha, where if I is greater than or equal to J, then it is not accepted by Griebach normal form. Now we will elaborately discuss about these normal forms, how to do this, and we will work out an example on this. So we'll solve a problem. So convert into Griebach normal form. We take a grammar S tends to AA bar small a, and A tends to SS small b. Now you have to name the rule number, what lemma 2 says, or the condition says, whatever the non-terminal exists over there, you have to name in conventions of A. That means S is a starting symbol, so I name S as A1. Now the second non-terminal, that is A, so I name A as A2. Then there are only two non-terminals. Now we will replace S by A1 and A by A2. So the actual equation becomes S is replaced by A1. So replace S by A1 and A by A2. So the equation becomes, when S is replaced by A1, becomes A1 tends to A is replaced by A2. So A2 bar A, and second equation, that is A is replaced by again A2. So A2 tends to SS is replaced by A1 bar B. Now when you take up the first equation, A1 tends to A2, that means A of I is always less than A of j. So this grammar, the first grammar, A1 tends to A2 is over. It's okay. And A1 tends to A, these two are actually accepted by Griebach's normal form. But where is the problem? When I value, that is A of 2, is greater than A of j. So this is not accepted. So somehow we have to replace this. So apply the value of A1 in A2. So apply A1 protection in A2. Apply A1 protection in A2. So when I apply A1 protection in A2, now A2 becomes A2 tends to. So first A1 is replaced by A2, A1, and then A1 is replaced by A here. So automatically when you replace A1 by A, it becomes A1, and the original production exists, A tends to B, so B. So this is the production. Now you have A2 tends to A2. Now this is called as a left recursive production. So if there is a left recursive production, you cannot do anything. You have to further evaluate it to apply a new concept called as Z over here. So this is a left recursive production. So this is A, this is alpha here, and this is called as beta 1, and this is called as beta 2. So based upon the theorem, you have to substitute it. Now where you get a problem, you get a problem in A2, because left side and right side are equal, so this is called as left recursion. So now you take it up, A2 tends to, take up the original production, A tends to A1 bar B. Now you have to apply the Z value. So A1, then apply Z over here, then B Z. We get an answer for A2. Directly you apply Z over here. Now apply Z equation. So Z equation, what it says, alpha, first you have to write alpha, Z tends to, alpha is Z tends to A2 A1 bar A2 A1 Z. Now I have got a set of equations now. A2 tends to AA1 and Z tends to AA2. Now what is the original equation of A1? A1 tends to A2 A. So normally Griebach's normal form has to start with a non-terminal. So it has to start with a terminal. So A2 is a non-terminal. So you have to substitute this A2 in A1. Now apply this A2 in A1. So apply A2 in A1. So this A2 equation has to be applied in A1. So it has to be applied in A1 equation. So when I apply it, so this A2 has to be replaced by A1 tends to, when you replace A2 by A1, so first A1, and already A2 exists, so you write A2 bar. Now if A2 is replaced by B here, it becomes B A2 bar, and you replace by A1 Z, so A1 Z bar A2, yes. Now you replace by BZ, A2 is replaced by BZ, so BZ A2, and already A exists over there, so you write A. So A1 have got that equation. Now you come to A2 here. So A2 tends to A1 actual equation, B A1 is it, B is it, and you take up the Z equation. So when you take Z equation, Z has A2 A1. Since it is a non-terminal, it is not accepted, it should start with a terminal, and here also A2 starts with a non-terminal. So this has to be replaced by terminals. Now apply A2 in Z production. When you apply A2 in Z production, A2 has A1. So Z tends to A2 is replaced by A1. Already A1 exists over there, so A1 here. Now bar, if we substitute A by B, now it becomes B A1 bar. Now if you substitute A2 by A1 is it, A1 is it, and already A1 exists, so A1 bar. Now if you substitute A2 by BZ here, so BZ, A2 is replaced by BZ, so BZ A1. And one more equation Z has another equation called as A2 A1 Z. So this A2 also has to be replaced by the respective values of A2. Again I write Z. Z tends to, now apply A1 in A2 Z. So when I apply it A1 is it bar. Now apply B here in A2 is it, B A1 is it. Now next one is A1 is it. In this format, when you apply, replace this A2 by A1 is it, A1 is it. Again one A1 is it exists over there, bar. Now you replace by A2 by B is it. So B is it, A1 is it. And if you take A1, check it out, A1 has the production which starts with terminals followed by non-terminals, and A2 also start with terminals followed by non-terminals. And you take up Z also starts with terminals and non-terminals. So that's it. This is called as Griebach normal form. Thanks for watching the video. Have a good day.